Welcome to all. We are nearing the end of ladder friction. That is almost end of friction also. That is part 4. Question 107. See, a ladder is placed as shown in figure. This is to save the time. Those who want words, see, a ladder is placed. See, one more thing they told. See, something they told here, dimension. See here, AC equal to 3.2 meter. BC, this time, first time I am doing anything, usually I take ABC. So so people will by heart. One reaction is RA, other is RC. No, don't by heart ABC. So this time, RA and RB will come. See, that much common sense required. So AC equal to 3.2 meter. See here, 3.2 meter. BC equal to 6 meter. See their height 6 meter. Then mu at A, they told, is 0.25. See, that's why 0.25 RA here. Mu at B is, there how much they told? 0.2. That's why, what? 0.2 RB. As usual, you have to write RA is normal reaction, RB normal reaction. Then, or if you want in words, a ladder is placed so that top of ladder is 6 meter above ground and bottom of ladder is 3.2 meter from the wall. Friction coefficient between ladder and the floor or ground is 0.25. Friction coefficient between the ladder and the vertical wall is 0.2. And then weight of ladder is 2.5. See here, weight of ladder is 2.5 kilonewton. If it is not given, understood, this is 3.2. So 3.2 means to center 1.6. See, when this is center of the ladder here, this is center of this length. Then, so this time, remember, make a note here. This time, preliminary part, you should do it. I am not doing it. After doing so many questions, if you are expecting, so write the preliminary part. We have to write everything. One more thing, see here. A person weighing 800 Newton is ascending the ladder with intention of reaching a point which is 0.75 meter below the top of ladder. You write a note here. See, that's very important. A person weighing how much? 800 Newton is ascending the ladder with the intention of reaching a point which is 0.75 meter below the top of ladder. Maybe he is doing some work on the wall, painting on the wall. He is where he want to paint. That level is from top 0.75 or little further upper side. So see, when you paint, you can lift your hand. So after he lifts his hand or some repairs, some window is there. Maybe you want to do some repair for the window. When it touches here, where his hand touches the window or something like that, that is 0.75 meter from top of the wall. Okay, then, so it is sufficient for him. Further he is not going. Why? It may be a wall further. Further up, if he goes, what he will do? Risky one. So he will stop the ladder. So he will stop somewhere here so that some work he will do here. Over. So therefore, that's the question given. Then find the, now what happened is the person who said the question, here me only, thought that if he goes to that height, see that height, the ladder is not stable. Before that, the ladder will slip. Because I know it. As he ascends the ladder, the person will not be able to reach that position. So what he will do? Someone he will tell there, hey, as I am going there, slowly push the ladder forward. Don't push too much. Prevent me from sliding. Now, find the least push required. I told you, least push required is the minimum push required. That is for limiting friction. Thousands of time I told. For preventing the ladder from slipping. For preventing the ladder from slipping, least push required is when the friction reaches limiting friction. If I tell further, so many people will tell, sir, how many times you are telling? Okay, this all you write. Then write here, RA, friction coefficient is mu A into RA, friction coefficient. Frictional force is FF limit at A is mu A into RA. I wrote this side because P is there. Actually, usually we write this side. Now, here I am written. Important is direction. See, ladder slips this way, friction this way. See, now P is actually helping the friction. See, yes, When friction is not sufficient, this P will help the friction. Okay, then slips down, friction up. This all you know it. Okay, then now solve the question. Only one point I will clarify now. See, when you place the person here, when you take moment about A, etc., see, we want this distance. See, wherever the person is standing along the ladder, we want distance of that horizontal distance of the person. Why? For taking moment. See, sometime they will give you this distance, sometime they will give you this side, sometime this side. Now he is giving this side they are giving, or they can give this distance. Okay. For that, see, I told here, this 2.8 meter, I will clarify now. See, this 2.8 meter, I will clarify now. I will clarify. I will clarify now. Now itself, I will clarify. For that, this complete I will remove. Or I can do one thing. I require more space for clarification. Therefore, I finish the question first. Okay, do one thing. Time now means, okay, not now, I clarify. I will clarify as soon as I finish solving this question. Finish this question. Okay. Someone will tell, sir, but how we finish? Time being, you believe me, 2.8. See, what data they are given in the question, as per that data, if you project this point here, from A, it is 2.8. You can believe me. First of all, when you come attend my class and study from me, whatever I tell you have to believe, no other alternative. Offline class I will tell, see, you have to believe me. Reply will come, sir, no problem, sir. That is all, you don't have to tell it. What you tell is correct. Sometimes in code book call, when I want to show something, everybody I can't tell. I will tell somebody, okay, you search the page number. At least some work you do. Sir, I will tell something. See, some provision is there. As per that one, this is so and so. They'll tell, sir, page number. Oh, you want me to give page number also. Do one thing. You IS code, when you go home, you take IS code, search and find where it is and make a note in the notes. Okay, sir. Some will be still telling, if sir tells page number, easy for us. See, lazy people. At least some contribution from you for involvement. But still sometime what I will do is, I will take the code here. See, this is which code? This is RCC code. Okay, IS 456. Somebody in the front bench, suppose imagine something is written there regarding some percentage, say, say something, 6%, I will tell you, for a column as per IS code, right now, suppose you see this class after some 10 years, who knows, IS code might have changed that number. Okay, right now, at 2025, I'm uploading this load, that is a June month, IS code, they are given there, maximum percentage of steel for a column is 6, not 6%, 6, or reinforcement for a column should not be more than 6%. I will open the IS code. Somebody in the front bench, I will take, see, I will randomly open a page. Then I will ask him, see here, read here, see, the 6, can you see it? He cannot see it. Why? I am showing a wrong page. But you know what he will do? Yes, sir, correct, sir. Yes, see, I will tell others. He saw it now search. Then as I turn that side, someone will ask him, page number. See, lazy people, he will tell, who knows? Sir has not shown me. He randomly took something. Then you told, I believe, sir. They will tell, I believe, sir, because that's all. See, it is a belief. Okay, now start. Sigma Fx0, take right side positive. See, what they told? Weight of ladder is 2.5 kilonewton, remember, and weight of person is 800 Newton. Oh, see. What happened is, something happened here. I wanted to trap you. I wrote here 800. I wrote 0.8 kilonewton there. I know it. I first thought of, I will tell you what, writing this way. See, okay, leave it now. Now anybody will catch it. Someone will comment there. 800 Newton. I want to write, I forgot it. I wrote correctly first. I wrote 0.8 correct. Why? When this is, if I take one of the answer in kilonewton, one of the value, all remaining should be in kilonewton only. You can't put in Newton. Meaningless it becomes. So I wanted to deliberately make a mistake. I wanted to write 800. Then I want to tell you, see here, sigma fx0 all over. So I will tell you now. See, when you do sigma fy0, I would have told you plus Ra plus 0.2 Rb minus 2.5 minus 800 equal to 0. So many people will be laughing. This person does not know unit. One he takes in kilonewton, one he takes in Newton, takes as it is. They will comment. But let them comment. But remember, when I wrote the answer, I took point. See, you can see here. First I wrote 0.8 into 2.8 only. Then 0.8 I changed to 800. So more space required. The 2.8, see, I squeezed it there. Why? It took more space, 0.8. Okay, now I am caught because my trapping almost failed because I forgot to make the mistake here. See, here I deliberately made a mistake. Here, 800, one in kilonewton, one in Newton. See, one in kilonewton, one in Newton. I deliberately made the mistake here just to please people who want to be happy by when I make a mistake. After everything is over, I would have told them, do you think it is do you think I can make such a mistake? See, when I calculate here, 2.5 into 1.6, it is a kilonewton meter. When I see Newton there, I can make out. Or how I can write minus 2.5 minus 800, that much common sense is not there for me. So deliberately I made a mistake, but by chance, what trapping or mistake I wanted to do, it is exposed because, see, there I wrote correctly. I forgot to change. First I wrote everywhere what? 0.8 only here. Suddenly thought, why not make a foolish mistake today, silly mistake, so that initially let people laugh. Once they laugh, later they will realize, oh, he is deliberately doing it to fool us, or he is doing this mistake just to warn us not to make the mistake. Okay, done it, leave it now, what to do. So this weight is how much? 0.8 kilonewton. Why? Since they told 800 Newton, since I took the weight in kilonewton, that should be in kilonewton. Okay, now I change it. See, now only, see, this is how much? This is 0.8. See, now space problem is, see, earlier I wrote 0.8 into how much? Into 2.8, see, into 2.8. At that time space, now later I made a mistake deliberately by removing this 0.8 and putting 800. Space problem came, so I squeezed 2.8. Okay, everything. And that's why I did not write the unit here. See, I wanted to act little confused. What is the unit here? Oh, there is something wrong here. See, one is in kilonewton, one is in Newton. Oh, I made a silly mistake. I will tell, I sincerely apologize. Then I will tell what apologize, deliberately made. Okay, now, but when I calculated, I did correctly. See, I took in kilonewton only. Okay. Okay, leave it now. One thing forgotten, you have to write one statement. I forgot to tell the statement. When you solve what they want in the question, find the least push required. So let P be least push required. Least, right here, least push required to the ladder at the bottom to prevent the person from, not from, okay, to prevent the person from falling down or to prevent the ladder from slipping. Okay, okay, now start. Preliminary part, you do it. Okay, sigma, now okay, sigma fx0 plus P plus 0.25 Ra minus Rb equal to 0, equation number 1. Sigma fy0, some will tell in the class, sir, everything understood, sir, no need of explaining. Okay, plus Ra plus 0.2 Rb minus 2.5 minus 0.8 equal to 0, equation number 2. Take moment about A. Minus Rb into 6, see here, minus Rb into 6, minus 0.2 RB into 3.2 plus 2.5 into 1.6 and also plus 0.8 into 2.8 equal to 0, you will get the value of RB here. Once you get the value of RB here, substitute in 2, you will get the value of RA. You should do it. Don't expect me to write. Once you get RB, substitute in 2, get RA. 2 is not visible. 2, get RA. Once you get RA, substitute RA and RB both in this equation, you get the value of P, that is 0.162 kilonewton. Now make a note here. Your P comes positive, means correct. So least force required is 0.162. Make a note. Suppose P comes negative. What it means? If P comes negative means when the person is standing there, ladder will not slip. It is not on the verge of slipping. It is still within the limiting friction only. Means slipping chance is not there. P will come negative. That is, limiting stage has not reached. This help is not required. So negative means what? If you want, you can pull it this way also. Dangerous. Don't do it. Okay. And rare coincidence, P coming exactly 0. That means when the person is reaching here, ladder is on the verge of slipping. So at that time, force is not required. But if he goes further upper side, push required. If he comes further downside, nothing required. It all right here. Okay, now this question over. Now I will clarify this 2.8. This full I will remove and everything I will remove now and clarify it. And I will tell you some small tricks also for you. Now on. Please take that. Because later in YouTube, all such tricks of getting distances relate when along inclined given, how to get along vertical, how to get horizontal, or along horizontal given, how to get along vertical, how to get along inclined, all along vertical given, how to get along horizontal, how to get along inclined. This all mathematical part used not for structure engineers. Anybody, including PUC students also, or degrees, even BSc also, or common public also, I will upload in the YouTube. There, sin cos I cannot tell. See, there I can't tell sin cos because if I tell sin cos there, people, general public, they won't understand sin and cos. Okay, I'll clarify now. I'll come back. Now I will explain that mathematical part. See, in the title I will write today's question is 107 in the bracket with some important mathematical concept, and then 108 next question. Okay. When I write such in title, you should observe why it is written. Anywhere in future in title, if I write something in the title, extra information, means it is for you. See here. Correctly observe now. Different versions I will tell you. This is the ladder position. See, little bigger. See, correctly now. See, this is A. A, B, C, D, don't by heart. This is B. This is B. Okay, this is B. This is C. And one more information I will give you. See, this length is full length. How much? 3.2 meter. This length is 6 meter. Okay, now, what in the, see, I will use the green color for what is given. So, I will use green color now. See, in the question given, you write that person weighing how much? 800 Newton. Okay, 800 Newton. But when you solve the question, you can is at how much? 0.75 meter below means vertically below top of ladder. See, now one doubt comes. See, he is standing somewhere here. See, green position, person. This is a person. See, dot is the person. Okay, I'll put the load here. It's weight. How much? 800 Newton. Okay. No. Okay, 800 Newton. But later kilonewton required. Remember, 800 Newton. In the question they told, this distance is 0.75, see, green color, 0.75 meter. That distance, green color is right. Now, someone will tell, sir, it can be this way also, no? He is below the top by 0.75. See, even if you measure from here, sir, he is below the ladder. See, when you tell below, in general understood vertically below. If he is here, they should have told he is at a distance of 0.75 meter along the ladder. Or if simply they tell as he ascends the ladder, he is at a distance of 0.75 meter from top of the ladder, that means this distance. I will tell you little later. That is this distance. But when they tell he is below by 0.75 means he is here. Now, one important here. You project here. Finally, what we want is, we want this distance. Why? This distance we want. See, red color is required. Red color is required. Required for, say, x naught. I will take this as x naught, horizontal distance. In ladder friction, see, when you take, see, sigma fx, this will not come. Sigma fy only load. See, only sigma f, is that green color visible properly? Sometimes what happens is, it's too faint. Okay, visible. Sigma fy, only load, 800 or 0.8. But when you take moment, see, if you take moment about this point, you require this distance. But usually, moment point is our choice. We will take about the bottom. It is our, see, when you take moment about a point, any point you can take. This all I will explain later with lot of principle in strength of materials or in extra uploaded classes for general principles. Lot of classes will be there. That is, some of them are eye openers, some are blunder. See, preventing blunders all. Okay, we want this distance. See, I told that distance is 2.8 meter calculated by us. See now, so many options are there for you. See, the best option is, see here, I will tell you best option. See, that's not required. Best option is, from top he is 0.75 meter. 0.75 with respect to 6 is, that also will do. See, 0.75 is the height covered with respect to 6 ratio rate. That will be equal to, very important, if you measure from here, you should take from here. That is, you do one thing, you mark one extra distance here. Extra calculation, black color, okay, black color. X dash, that will be equal to x dash divided by 3.2. Y from there, see this Y I have to take from here. I won't explain much now. See, when you stand here, this position, you see, it will come and touch here. Project it. From there you have to take distances. You should project, see how you measure 0.75, that you project for the touch here. If you take some distance here with respect to this length, you have to mark from here, x dash. This will give you x dash equal to, see how much it comes. This will give, I will give one more option for you, x dash equal to 0.75 divided by 6 into 3.2. It will give you 0.4 meter. It will give you x dash equal to 0.4 meter. So once you get x dash, therefore our x naught equal to, with red color, see our required value. Therefore our x naught equal to 3.2 minus x dash equal to 3.2 minus 0.4 is 2.8 meter. Red color. What I want? Red color 2.8 meter. See, this red color value 2.8 meter. 1 minute. Sometimes what happens is I go too close. I think I can move the camera. No, not required. Okay, space is there. That is one of the options. Or you need not find the x dash and struggle. Other way is, see, other way. It's another way. Other way is when this is 0.75 meter, you find, see, all this, remember, I am explaining mathematical concept. You find what is this distance. See, when you want distance from bottom of the ladder from here, this distance, you measure that, mark that point from the bottom. Again, green color, why? When this is 6 meter, this is 0.75. So, this will be 5.25 meter. Calculated value, not given. See how from 6, subtract that one. I need not show that calculation because nobody is that much weak in mathematics. 5.25. Now do one thing. Now see here. See, this is by relative position. This point from bottom is at 5.25. So, that 5.25 distance from here to here is with respect to 6 divided by 6. That will give rate along the height from here. That will be equal to, see, when you mark distance this way here, from here, this way it is not from, see, if you take ratio from top, it is this distance. If you take ratio from here, it is from here, not from there. Why? Because you are marking from bottom. Come to bottom point here. That is equally important. See, equal to x naught, your required value, x naught divided by 3.2. 3.2. That will give x naught equal to, it has to give 2.8 only. Divided by 6 into 3.2. 2.8 meter. It has to give x naught equal to 2.8 meter. Yes. Or directly, see, directly your x naught equal to, see here. I want from bottom. Project the bottom at this point. See here. If this is 5.25, this is 6. You calculate 5.25 by 6. That is the ratio of distance of this point from here with respect to that one. Same ratio multiply by 3.2. That's all. See, why I am wasting time, I don't know. 2.8 meter. I am checking, not checking, equal to 2.8 meter. Okay. Now, this is clear. Now, make a note here. Suppose in the question, see, suppose in question, see, question, that is same question. They want right here, same question, they want same data. Means what? They want the person to stand here only, not to move. They can give, suppose they gave, see here, I go for green color now. Why? Given value, given is green color. See, suppose given that person is at a distance of, I should now calculate and give. I can't give directly. Or for that, I should know the length of the ladder. 1 minute. 6 square plus 3.2 square equal to root answer equal to. Oh, it's a fractional value. How? 6 square plus 3.2 square equal to root answer. Oh, fortunately, round number. Oh, good. 6.8. 1 minute. 6.8. 6.8 means how much it is? 0.75 by 6 into 6.8. Don't worry. In the question given, at a distance of 0.85 meter. It is actually same question. Meter from top of ladder. Top of ladder. Suppose they tell at a distance of 0.85 meter from top of ladder. See, suppose nothing else given. In that case, you write that means it is they are giving this distance for you. How much? 0.85 meter. Not this one. They are telling you that distance. Why? Because when he goes along the ladder, till he is at 0.85 means, or either they can give only this much, or they can, to avoid confusion, they may add one more statement, 0.85 meter along the ladder from top. Okay, crystal clear. Then, see, then what happens? we want x naught. See how to get x naught. See, from here 0.85. Then you require length of the ladder. See, now you require length of the ladder. Length of ladder you require. You calculate length of ladder equal to 3.2 square plus 6 square root. If you cannot calculate, do one thing. Right now, leave my class and study somewhere else. 6.8 meter. So, I won't write here now, so I remove this one now. See, that is how much? See, this is 6.8 meter. What is this? Going inclined way. Okay. This is 6.8 meter. Okay. Then, still we want this distance only. See here. He is standing here. From here 0.85. Do one thing. X naught you require. From the top of the ladder, he is standing at 0.85. So, 0.85 is the ratio proportion with respect to 8. See, 0.85 divided by 8 will give his proportionality value with respect to top. You want from here. Don't take into. Now, see, you want from where? From horizontal you want. So put your finger here. So see, finger should be here. 0.85 is the distance along 6.8 unitless. That ratio, you project this point to horizontal plane. See, that will give you this distance, say x dash. So your x dash equal to 0.85 by 6.8. What proportion is there from top? That into this distance will give you distance from here into what? Into 3.2. Why? In 6.85 in 6.8 means how much in 3.2? But remember, your finger should be here. Means you project here and write. Your x dash will come. Y calculate. 0.85 by 8 into 3.2. 8, 0.8 by 6.8. Ayo. 0.85 by 6.8 into 3.2. It will come 0.4 meter. So you got x dash equal to 0.4 meter. Therefore, what we require x naught. Therefore, our x naught equal to how much? 3.2 minus x dash. 3.2 minus x dash equal to 2.8 meter. 2.8 meter. Okay. Or 1 minute. Or right here. Or suppose in the question they give that person is at 5.95 meter. 5.95 meter from bottom. From bottom. Means doubt comes. How 5.95? Height wise or length wise? When nothing given, he is ascending the ladder. He is at 5.95 meter from bottom of ladder. Means they are giving you this distance. See, this is the green color value. Or they may give this much only. Or some kind people are there. They may think, oh, some student may take wrong distances. He may take it here. Therefore, to make it more safer, to help you, he may tell that person is at 5.95 meter along the ladder from bottom. How much is 5.95 meter green? Then your x dash, x naught will directly come. See here now. Then your x naught equals here. Along this ladder, see, you stand here. From here, he is at 5.95. He is at 5.95 with respect to how much? This is 6.8. It's known value. It is 6.8. See, not red color, black color. This is 6.8 meter. So he is at 5.95 along a length of 6.8. So it is 5 point how much? 8. 5.885. 5.95. Or your x not equal to color problem. X not equal to 5.95 given value, that is a green color value, given value 5.95. 5.95 in 6.8 by 6.8 means the proportionality constant is 5.95 by 6.8 along the ladder, means you are standing here, so project here, from here you will get directly that the same proportion he is standing with respect to 3.2. So multiply by 3.2. 5.95 divided by 6.8 into 3.2 is 2.8 meter, red color value. What you require, we got 2.8 meter. Okay, now I'll give one more alternative for you. See, this is 2.8 meter. Okay, now further more option I'll give you. See, I want little more space now. See, little more space I want. I'll give one more option for you. Suppose people get confusion. Sir, I am getting confused, sir. This ratios all no, sir. I want a crystal clear calculation. Okay, no problem. See here. I remove this one now. This is not required. This sketch is not required now. Okay. Or now we do one thing. You got one more option. Once again go back. See, once again go back. See, this height is 6 meter. See, I am telling everything now. You take whichever option you want. 6 meter. Okay, see. Once again come back. Okay, start. Right here. One question. Right here. Suppose in the question they gave, the person is standing at how much I told? 0.75 meter below the top of the ladder. This one. Once again I am doing 0.75 right here. He is standing at 0.75 meter below the top of the ladder. Okay, then we want this distance. You know, what to do is, you take one triangle here and one full triangle. You take this as x dash. See, now from similar triangles, x dash divided by 0.75 x dash by 0.75 equal to 3.2 by 6. 3.2 by 6. I'm not using color now. Color I'm not using. X dash equal to 3.2 divided by 6 into 0.75 is 0.4 meter. See, 0.4 meter. When x dash is 0.4 meter, see here, this is 0.4 meter. Therefore, your required value x naught equal to, therefore your x naught equal to total 3.2 minus x dash will come 2.8 meter. Okay. Now, or one more thing, you calculate this theta. If that is theta, this also theta only. Calculate theta. Tan theta, you take the full triangle here, equal to 6 divided by 3.2. Therefore, get theta. 6 divided by 3.2. Shift tan inverse, answer 61.9275 degrees. 61.9275 degrees. Then, in this triangle, you connect 0.75 and x dash. What is that one? Tan theta. Once again, see, here tan theta, actually waste of time. And now tan theta is once again equal to 0.75 by x dash. Therefore, calculate x dash. Tan of that number, whatever I got, I will store in memory now. Store in A because fractional value. Okay. Tan, calculator is off. Okay. Tan of, store A, tan A, 0.75 by tan theta. See, 0.75 divided by what? Divided by tan of shift store A is 0.4 meter will come. X dash will come 0.4 meter. Therefore, your red color value x naught equal to. See, this is applicable not only for this question, any question in future. X naught equal to 3.2 minus x dash equal to, substitute, 2.8 meter will come. Okay, now one more. Or in right here, or in the question, if they tell the person is not 0.75. Why, I forgot it now. What is that one? I can calculate also. See, 0.75. What is that length of ladder? I forgot length of ladder. 6.85 meter. Okay, 6.85 meter. Anyway, forget it. While setting the question, the person will tell 0.75 by 6 into 6.85. How much it is? 0.75 by 6 into 6.85. No, it is not 0.85. 1 minute. What is the length of ladder? 6 square plus 3.2 square equal to root answer equal to 6.8. It is, how much it is? 0.75 height with respect to 6 into 6.8 is 0.85. Oh, suppose in the question he gives, you write here, the person is, you should write second option, the person is standing at 0.85 meter from top of ladder. So if it is not given, understood that he is giving not this one, see, he is telling you this distance. How much it is? 0.85. Green color value is this one now. He is telling this is 0.85. Why? Understood. Or just to avoid your confusion, he may tell 0.85 meter from top along the ladder. Okay, then do one thing. Put bracket here. This is x dash. Now you require length of ladder. Calculate. Length of ladder is 6.85. See, now length of ladder required, it will come 6.85 meter. Now apply similar triangles. What you get? See, x dash by 0.85, x dash by 0.85 equal to, see, x dash by 0.85 equal to 3.2 by 6.85. 3.2 by 6.85, you will get x dash. 3.2 by 6.85 into 0.85 is, what is this one? 3.2 x dash, x dash by x dash by how much? 0.85 equal to 3.2 by 6.85. So x dash equal to 3.2 divided by 6.85 into 0.85. So, why wrong number is giving? 0.85 correct? 0.75 with respect to 6 into 6.8 is 0.85 correct. So, what I wrote? X dash divided by 0.85 equal to 3.2 by 6.85 correct. X dash equal to 3.2 divided by 6.85 into 0.85. Why giving wrong number? What went wrong? Some number is missing here. 3.2 correct? 3.2 is correct. This is 0.75. 0.75 with respect to 6. Is length of ladder is correct once again? Again I am getting confusion. Dimension problem. 3.2 square plus 6 square equal to root answer equal to 6.8. 6.8 meters. See. It is 6.8. See, I was wondering what is problem. See, such things cannot happen in my class. Ruled out. One thing I will tell you. This is forgetting. See, it is 6.8. I am not at all in tension, not worried, no what you call BP rising, not bothered. I know mistake will be known. So therefore, see, x dash divided by 0.85. See, if this is not clear, I can't do anything. X dash by 0.85 equal to 3.2 by 6.8. Now x dash will come 3.2 by 6.8 into 0.85. 0.4 meter. 0.4 meter. Therefore, your x naught equal to how much? 3.2 minus x dash will come 2.8 meter. Okay. Or one more thing. You take this angle theta. Calculate theta. How much theta will come? You know how to calculate theta. How much it is? 6 divided by 3.2 tan inverse. 61.9275 degrees. Okay, theta non. Now, see here. Once they give 0.85, you connect here. Then what happens now? See, connect this side. Last time using theta, you connected this with what? 0.75. Now, this with this one. So, what? Cos theta equal to x dash by 0.85. Therefore, you get the value of x dash. How much? X dash will come 0.85 into cos of shift store A, 0.4 meter. One x dash come to 4 meters here, x naught equal to 2.8 meter. This also I covered. Now, last case. Suppose in question they gave this I already told you, instead of 0.75 meter here, they can tell you 5.25 from here. I already clarified. They gave the person is standing at 5.95 meter from bottom of ladder. You write everything. See, even if it is clear, it is useful for you full mathematics. Okay. Then, see, that means in the question they are telling you this distance, see, this distance. Now, remove it. They are telling you this distance. How much? 5.95 meter. Understood. Along the ladder. Or they may tell clearly along the ladder. Okay, then, see, x naught, actually direct answer. How? Already I told you earlier, 5.95 by 6.8 into 3.2. I already told. Now using calculation, then what to do is, see here. Then you consider this triangle and full triangle. Similar triangle will give you, see, x naught divided by 5.95. Your x naught divided by 5.95 equal to 3.2 divided by 6.8. Directly you get x naught. 3.2 by 6.8 into 5.95. Oh, it will become 2.8 meter. What we wanted, we got 2.8 meter. Or do one thing. Or if you don't like this one, go for trigonometry. Or find theta first. Same answer. How much theta will come? Shift store A. 61.9275 degrees. Or those who want, write, see, full triangle. Tan theta equal to 6 divided by 3.2 get theta. Then you connect, see, in this triangle, you connect this height with this side. No, you connect this side with this side. How? Cos theta equal to directly x naught divided by 5.95. Therefore, your x naught equal to 5.95 into cos of shift store A. That is 2.8 meter. 2.8 meter. Okay, this also over. So, remember, I first thought today I will do one more question, then next class 2 questions are there. Okay, no problem. All are easy questions. So, next class I will do next question because already it is taken more time now. So, I don't have to write question 107 with the mathematical concept and question 108. I can write question 107 with plenty of mathematical concept. Important for you, something I will write. Now, lastly, right here, note. Suppose in the question, this someone will tell, sir, this you are wasting time. Yes, I am wasting time. Right? Or suppose in the question, they give the person is at a distance of, person is, see, I forgot, right? This, you want x naught here, red color. We want this x naught. Suppose they tell the person is standing in the ladder in such a position which the horizontal distance, see, they will tell you horizontal distance from wall is 0.4 meter. What is 0.4 meter. That means what they are telling? They are telling this distance is 0.4. Right here, one sketch. Then this is not required. This is not required. 0.4 meter. Ayyo. Then this is a Kannada word actually. I see sometime when you explain some, exclaim, not explain, exclaim, like natural mother tongue only will come. See, whatever happens, suppose you talk to yourself. Sometimes everybody will talk to themselves. See, sometimes in the traffic I talk. Nobody is listening. I will tell, hi, what these people are going, all elbows. I comment myself only. Some will tell, oh, this person thinks he is an expert. I am good expert in driving. I never make mistakes. But therefore, I will tell, if nobody, suppose I am driving a car or a bike, I will tell myself, elbowed case. Or Kannada I will tell, elbowed. Elbowed is English only. So suddenly I told, you. See, then someone will tell, sir, what is this, sir? This much you are knowing. Okay, you know it, but learn from me. They are telling you green color, okay. They are telling you green color is 0.4 meter. Now if you cannot calculate x naught, x dash equal, not x dash. See, they are telling you this distance is 0.4 meter. Means this is also 0.4. Now if you cannot calculate this distance, do not do anything. Leave the subject, go somewhere else. Or last one. Or in the question, suppose they give one more sketch you write. The person is standing at a horizontal distance of 2.8 meter, horizontal distance of 2.8 meter from bottom of the ladder. Oh, they are directly giving you what? X naught equal to 2.8 meter. 2.8 meter. Okay, thank you. You solve. Then this is not required. So this is mathematical part. Anyway, later I will tell you one class, full class, mathematical trick of not only right angle triangle, see, need not be right angle triangle, even it can be any triangle this way. See, if a point is given at some proportion from here along this length, how to fix this length, how to fix this length, project here, how to fix this length, how to fix this length. Or suppose they give, you see this ornament here, see this way, or one thing, see, if they give this point, position, how to fix these two distances, or suppose they give some position here, see, project it here, how to decide this distance and this distances, or if they give some position here, along here, see, then, see, how to fix these two distances, or even for random triangle also, see, not right angle. Suppose some point is here, see. Along this length, they will tell how much this one or how much this one, how to get these distances or these distances. Or if they give this distance or this distance along this length, how to decide this one and this one, this one and this one. Or if they give this distance and this distance along this length, how to get this distance and this distance. Very carefully you should do it. It will be a mathematical trick, so that nothing required. All you require is, see, once you got good confidence, you write some answer. See, you should surprise. Suppose you go to interview, you should write this way. Somebody will ask, what is the distance? I don't know which one. You should write this way. Okay. He will ask, hey, how you got it? Sir, mathematics, sir. What do you think of me? But remember, sometime it will become, see, sometime it will become some other way. It may be 1.2, 3.2, 4.8. This way, something minus something may also come. Be careful. That you should be careful. This, again, if you write this way, they will wonder, how you wrote so fast? How you know it's subtracting? Sir, mathematics, sir. I am expert. Don't tell that way in interview, danger. But he should think, oh, this person has got so much mathematical knowledge, so good. Even if he does not know subject, or for office purpose or design purpose, I am talking about structural engineers. He can be taught because he got the mathematical instinct. Mathematical instinct or knowledge or grip or control is something which will take you great heights in any field, in any scientific field, or especially in structural engineering. I told already, everything for entire my present capacity in structural engineering entirely due to mathematical grip. That's all. See, mathematics will never let me down. Therefore, I will never let structure down. So, mathematics will not let me down. So, I will not let structure down. Okay, that's all. Now, lot of talking I have done. So, I will close now. Next question, actually nothing is there. Same as today's question. Somebody is ascending the ladder. To prevent slipping, some weight required here. Actually, and one more question is, a cable is attached here, find tension in the cable. So these two, nothing to explain further. So tomorrow, next class, I will write the question, solve, I will tell you complete. Otherwise, don't continue my class. This already solved earlier. One more question. Then one critical question is there, where reactions are to be reversed. Reversed. I will tell it with concept. Very important. And briefly I will tell here, severe concept I will upload in the YouTube as a special structural concept. Okay. Thank you. Next class we will meet. Go through each and everything.